Okay, so here are our two learning targets. First, we're going to work on defining what a polygon is and give some examples of polygons. So what we're going to do on the next slide is some examples and non-examples. Okay, scroll down just a little bit. So first of all, what is a polygon? A polygon is a closed plane, which aka means flat, two-dimensional figure with straight sides. Okay, so we're just going to go through that criteria for a couple of them and see if they meet or not. Okay, I'm going to start right here with this half circle or semicircle. And I can see that the thing that disqualifies this from being a polygon is it does not have straight sides. So I'm going to cross that one off. Okay, next we're going to look at this green triangle. Is this flat? Yep. Is it closed? Yep. Does it have straight sides? Yep. So this is a polygon. Yay! Polygon. Okay, over here we have an oval. Right away I can see not straight sides, not a polygon. Okay, how about this star right here? I see it is closed. It is a flat plane shape, and it also is has all straight sides. Yay, polygon. Okay, star here. Oh, I see curved lines, not a polygon. Right here, ooh, this bottom one right here. Sure, it is flat. Sure, it has straight sides, but do you notice that it is not closed? It is open, so this also cannot be a polygon. And then lastly, these two here, we have a hexagon, straight sides, closed, and flat. Yay, good, this is a polygon. This is also a polygon, okay? And then over here, we have a quadrilateral, actually a parallelogram, and this also is closed, has straight sides, and is flat, plane shape, is a polygon. Yay, okay. Next thing we're gonna work on is describing and classifying quadrilaterals and triangles. So there are two ways that we classify triangles. The first one is by angle measures. So if you remember from fourth grade, you may have used this tool right here. This is called a protractor. And what this does is help us measure angles. Okay, now you don't have to be super specific in your measuring today when we go to classify these, but we're going to look at these angle measures down here. I'm going to pull these up a little bit. And we are going to classify these triangles by their angle measures. Okay, and you might be thinking, Miss Brocker, are you crazy? Those aren't even triangles. Yes, I know. But these are our line segments that are going to make our triangle. So if you want to imagine another line here or here or here, that would be okay. Okay, now what we're going to do is we're going to look at these angle measures right here. So right here, and right here. And this is something you should remember from fourth grade. When we have a little teeny tiny angle that is less than 90 degrees, we call this an acute angle. And actually, these signs are not right. This should be it. Our angle is less than 90 degrees. 90 degrees is greater than our angle. Okay. If we have a right angle, see how this is kind of like a half square right there that shows us a right angle? That means that angle is exactly 90 degrees. And then obtuse, big, giant, open angle greater than 90 degrees is an obtuse angle. Okay. Okay. Next way, and you can see these in actual triangles. Here we have our obtuse. Here we have our right angle. And here we have actually more than one acute angle. Okay, next way that we classify triangles is by their side length. So I'm going to scroll down a little bit so we can see our names. Now, one thing that's important for you to remember from fourth grade is, do you see these little marks right here and right here and right here and right here and right here? What those mean is that these side lengths are all the same. Now, if they were different, you might see like 3 lines here, 1 line here, and 2 lines here. That shows that they are all different side lengths. But when you have the same lines, means they are the same. So even though we don't have like a 5 and a 5 and a 4 here, we know that these side lengths are the same because of those marks. Okay? Okay. So if you have a triangle that has 2 sides that are the same, this is called an isosceles triangle. So 2 sides are the same. We can tell that by both our lines and by 5 and 5. Okay. Scalene triangle, that means that the triangle sides are all different, and equilateral means they are exactly the same. Now, one hint I gave you in class yesterday, I know it's not spelled exactly right, but look in here. You can find out and pull the word equal, E-Q-U, and then switch these around, A-L, okay? So even when you say this out loud, listen to me, equilateral. It sounds like I'm saying equal. Scalene, all different, isosceles, 2 that are the same.